Okay, so this is Unit 4 Review Guide, number 3, end behavior. So first thing you want to know is what are the rules for end behavior? So to determine the right side of it, we look if the coefficient is what? So for the right side, we look if the coefficient is positive, the right side goes up. If it's negative, the right side goes down. If I want to figure out the left side, I look at the... You can talk. Someone say something. You look at the degree. If my degree is even, left matches the right. If my degree is odd, my left does the opposite of the right. So these are your rules. And part B says negative 3x, is that to the third? Minus 2x. So the first thing I do is I look for the right. And for the right, my first number is negative. So the right is going to go down. I want to look at the left. My degree is odd, so the left is going to do the opposite, meaning it's going to go up. Now you don't leave your answers like this, but you can think of it as a graph that would do this. The right side's going down, and the left side is going up. So how would I rate the end behavior for that? I would say as x goes to infinity and as x goes to negative infinity, the left side, so this is the right side here, right? As x goes to infinity is the right. So f of x goes to negative infinity. And in the other case, the left side, f of x goes to positive infinity. Turn that sideways a little bit. Does that make sense? Okay. So that's end behavior. Okay, for number 5, it asks you to find the zeros through the long method. Long method says we take factors of the back and divide it by factors of the front. Factors of the back are plus or minus 1, 2, 5, 10. Factors of the front are 1. And you're looking for whatever one of these. You have 8 choices. You're looking for which one makes the whole thing equal to 0. Remember, we said you can use your calculator for that. So if you just graph that whole line, you could trace 1, negative 1, 2, negative 2, 5, negative 5, so on. See which one would actually give you 0. And which one was it? I think it's 2. Is that right? So I'm going to put 2 in the box, and that's one of my solutions. Synthetic division, so 1, negative 2, negative 5, 10. Bring down the 1, multiply, add, multiply, add, multiply, add. Final answer, drop the degree by 1. So I have x squared, there's no x, minus 5 is equal to 0. I want to solve. There's no x term in here, so I just add the 5 over. X squared is equal to 5. X equals plus or minus root 5. So I have 3 answers. 2 and plus or minus root 5. So if you graph this original one on the calculator, your 3 zeros would be these 3 right here. Okay, so we want to do long division. So I'm going to do the same thing, put it in a bar. I'm going to scratch this out, put the x plus 3 right there. First question you ask yourself is x times what is x squared? And that answer would be x. Then I multiply. X times x is x squared. X times 3 is 3x. And then we subtract the whole line. The x squareds go away. And 10 minus 3 is 7. Bring down the 21. X times what is 7? X. 7. And then we multiply. 7 times x is 7x. 7 times 3 is 21. No remainder. So my answer is x plus 7. Does this one ask us to prove? Yeah. So to prove, what do? I take the answer I have and I multiply it by whatever I was dividing by. If you had a remainder, you would add that on afterwards, but your remainder is 0 in this case. So I'm going to say x plus 7 times x plus 3. To multiply that out, you FOIL. First times first is x squared. The outer gives you 3x, the inner gives you 7x. Last times last is 21. Combine the middle, x squared plus 10x plus 21, and that's what you started with underneath. Number 7, divide synthetically. So I know the number that goes in the box is going to be a negative 2. What do we have? 5. Now here's the tricky part. What's missing? There's no quadratic term, right? So we're going to put a 0 in. We need to put a 6 and then a 8. Draw my line. Bring down the 5. Multiply. Add. Multiply. Add. Multiply. Add. So it was originally cubic, so now I have 5x squared minus 10x plus 26, remainder 44. And negative 44, thank you. And I want to prove. So to prove this, what do? We still multiply back out. So what was I originally dividing? It was x plus 2 I was dividing by, right? So I'm going to say x plus 2 times 5x squared minus 10x plus 26. And when I'm done with all this, what do I do with my remainder? I add it on, but it's a negative, so when I'm done with all that, I'm really going to subtract 44. So distribute the x through everything. So 5x to the third minus 10x squared plus 26x. Run the 2 through everything, plus 10x squared minus 20x plus 52. Combine like terms, 5x to the third. What do we have? Negative 10x squared and positive 10x squared. So those go away, which is looking good because we didn't have a quadratic term in the first place. And then we have plus 26x minus 20x is plus 6x. And then what? Plus 52. Now, when we're done with this, what did we say we were supposed to do? Subtract the remainder. So 5x to the third plus 6x, and 52 minus 44 is a positive 8. And that's what we started with, right? 5, 6, 8 checks out. Make sense? Okay. So number 8, we're going to try again. And what do we have? 2x to the third plus 2x squared plus 3x plus 5. We're dividing it by x plus 1. We're going to do synthetic division, so negative 1 in the box. Coefficients are 2, 2, 3, 5. Bring down the 2, multiply, and then add, multiply, add, multiply, add, gives us 2x squared plus 3, remainder 2. It asks you to verify using the remainder theorem. So there's 2 ways you can verify, so let's look at them both. If you do what's called the remainder theorem, that means you take the number that was in the box, or the number that would have zeroed this out, and you plug it in. So this is into here. The number I'm plugging in is negative 1. So negative 1 to the third plus 2, negative 1 squared plus 3, negative 1 plus 5. Negative 1 to the third is a negative 1, because negative 1 times negative 1 is 1 times negative 1, so negative 1 times 2 is negative 2. Negative 1 squared is positive 1. Positive 1 times 2 is plus 2. And then, so these cancel. Over here I have minus 3 plus 5, and negative 3 plus 5 is 2. And that is what my remainder was. So the remainder theorem says that if you plug the number in the box into your equation, you should come up with what the remainder was. And then the other way to prove this is right is to do 2x squared plus 3 times x plus 1, and when you're done, add your remainder of 2, and you should come up with what you started. Any questions? Good? Okay. Okay, number 9 says that you have 3 4 minus I. It doesn't tell you anything else, but if you know 4 minus I is a root through the conjugate zero theorem, you know also 4 plus I is a root, and it wants you to work backwards to find the original polynomial, and then after that, they want you to prove that you're right. So the first part is let's find the polynomial. So to find these, you work backwards and you say if 3 is a 0, then x minus 3 is a factor, x minus 4 minus I is a factor, and x minus 4 plus I is a factor. I want to take these two over here, and I want to FOIL them out. I'm going to bring the x minus 3 down later. So when I FOIL these out, x times x is x squared. Now I just do this in real slow pieces. I'm going to say the outer now is x times this. This x is positive. This stuff is negative, and a positive times a negative is a negative. So I'm just going to write out what it was, 4 plus I. The inner is x times the quantity of 4 minus I. The x is positive, this quantity is negative, and a positive times a negative is a negative. X times 4 minus I. And last times last. Negative times a negative is a positive. And what were our quantities? 4 minus I, 4 plus I. Okay, next line. So I have x squared, do some distributing. Negative 4x minus xi minus 4x plus xi. When we come to the last part, 4 times 4 is 16. Then you're going to end up with outer and inner. They're going to cancel, right? Because you would have plus 4i minus 4i. And then last times last gives me negative I squared. And negative I squared is negative 1. So that's like saying negative 1. So that's really like saying plus 1. So that's like adding 1 to the end. So your 16 is really going to turn into a 17. So we have x squared minus 4x is negative 8x. Negative xi, positive xi cancel out. I have plus 17 at the end from the 16 plus 1. And now I'm going to bring down my x minus 3. So we're going to distribute everything by x and everything by negative 3. Everything by x gives me x to the third minus 8x squared plus 17x. Everything by negative 3 is minus 3x squared plus 24x minus 51 from negative 3 times 17. Combine like terms, x to the third. What else do we have? Negative 8x squared, negative 3x squared is negative 11x squared. 17x and 24x is 41x minus 51. So that's our actual equation. Is that what you guys got? Yes? Okay. So that's our equation. And then part 2 says, prove this is correct. How do we prove that that's correct? So we start over, if you look at the one we just did a second ago, it was number, which one was the longer method? Number 5. So to prove it's correct, it's like number 5 in your packet. You pretend this is the equation they give you. It says find the zeros by using the long method. So if I find the zeros, what should my zeros be? 3, 4 minus I, and 4 plus I. So I'm going to get a new piece of paper here. So we're going to start right with this one, and I want to find factors of the back over factors of the front. So my suggestion would be to just plug this into your calculator and see which zero works. So I have factors of the back, which would be 1, 3, 17, 51. Front number is 1. So we have that. It's plus or minus. Did anybody do this already? Yeah. What is the correct zero that I'm looking for? Negative 3. So I have negative 3. And again, you could find out on your calculator, right, by graphing it, tracing them out, seeing which one gave you 0. So I have negative 3. And I'm going to do synthetic division, so I have 1, negative 11, 41, negative 51. Bring down the 1, multiply, add, multiply, add, multiply. It's getting big. What do I got here? 249. Negative. And add, what's that give me? Negative 300. So something went wrong here. Shouldn't be. Did I skip a symbol? Was it supposed to be positive 3 in the box?
Yes, it's supposed to be positive.
Supposed to be positive. And you're lying to me. Alright, so let's, I'm not recording this whole video thing again, so let's do this again. So forget this, it should have been positive 3 in the box. Let's try again. So if I put positive 3 in the box, 1, negative 11, 41, negative 51. Bring down the 1, multiply, add, multiply, add, multiply. There we go. Now I got a remainder of 0. So this is x squared minus 8x plus 17. I want to set this equal to 0, and I want to find its zeros. How do I go about doing that? I use the quadratic formula. So let's make an ABC box. So A is 1, B is negative 8, C is 17. So negative B is a positive 8 plus or minus the square root of B squared minus 4AC all over 2A. So we have 8 plus or minus, what do we have here? 64 minus 68 all over 2. 64 minus 68 is a negative 4, so that's 8 plus or minus the root of negative 4 over 2. And what is the square root of negative 4? 2i. So this is 8 plus or minus 2i over 2. And the triangle thing you were just referencing is if these 3 that make a triangle are all divisible by something, you can divide out. 8, 2, and 2 are all divisible by 2. So that's 4 plus or minus I. So here's 2 answers. And my other answer is the one that's in the box.
Isn't it over I?
What's that?
Oh.
No, 4 plus I, 4 minus I. And here's 3. And that should match what we just started with, right? Beginning of the problem, 3, 4 minus I, and 4 plus I. Now, look at what we just did. I wasn't paying attention. Remember when I let Ann tell me negative 3 for a 0? I should have known that's wrong because the problem told me the zeros to begin with, right? So I should know 3 ought to be the one going in the box, right? So that's actually a shortcut. You don't even have to, when you're proving it, right? If they give you the zeros in the first place, out of these 3, which one's going to be the one you use for synthetic division? It's not going to be 4 minus I or 4 plus I, right? So this one right here would be your synthetic division number. Make sense? Okay.
It was supposed to show all of them.
Yes. Okay, so this is number 10. They give you a polynomial. They ask you to find a whole bunch of stuff here. They ask you to find possible rational roots, possible real plus imaginary, complex roots, and zeros. So the one I'm going to start with is complex. If you remember that theorem we learned, complex roots, first off, complex is the combination of real and imaginary, right? And we learned that whatever your degree is however many complex roots you have. So in this case, my degree is 3. So however many complex roots, in this case, what's going to match, so it would be 3. Possible real plus imaginary. What do I know about imaginaries? They have to occur in groups of 2. So I know I have a total of 3 answers, right? So I could have 3 reals. If I have 3 real answers, how many imaginaries do I have? 0. Now, can I have 1 imaginary? I can't have 1 imaginary because they occur in groups of 2. So I could have 2 imaginaries, 1 real. Can I have 3 imaginaries? No, because they occur in groups of 2. Could I have 4 imaginaries? No, because what's my total number of answers? So I've listed all the possibilities. So now, if it, say for example, maybe I had a degree 5, then I could list 4 imaginary as one row, but I can't go past the complex, right? That's my total. And my imaginaries are always occurring in pairs. Possible rational roots, you already know what that is, you just don't know the wording behind it. Possible rational roots is factors of the back over factors of the front. So possible rational roots would be plus or minus 1, 2, 3, and 6. Zeros means do the math. Do the long method, so find the one that makes it 0, synthetic division, and go through and solve. So we've already done that a couple times. There's no need to do that one again. Yes?
How did you get the 1, 2, 3, and 6?
Factors of the back over factors of the front.
So we don't have to list numbers, but we just list the 3 odds.
Yeah. Now for this one down here, when it says find the zeros, you would go through and do the math, find the one for synthetic division, and then go on through.
Okay.
Okay, it says graph the polynomial inequality. So first thing I want to do is I want to bring everything to the left and set it equal to 0. So I'm going to have x to the third plus x squared minus 4x minus 4. It's greater than 0. So if it's greater than 0, I know I'm looking for what type of answers? Looking for positive. So now I'm going to set this equal to 0 and find its zeros. I have 4 terms, so I'm going to solve by factoring, which is really when you have 4 terms, solve by grouping. So I underline these ones and these ones. From the first 2, I can pull out x squared, leaves me x plus 1. From the other one, I pull out negative 4, also gives me x plus 1. We're now setting it equal to 0. Take the grouping on the outside, x squared minus 4. Take the grouping on the inside, x plus 1. X squared minus 4 factors into x plus 2, x minus 2. We have x plus 1. So I want to solve, so what are my zeros? Negative 2, 2, negative 1. So I'm going to take these zeros, let's make another piece of paper. Take these zeros and put them on a number line. So what do I have? Negative 2, negative 1, and 2. So how many regions did I create here? Not 3, but I have 1, 2, 3, 4, right? So I want to plug into, here's back to the problem. So this problem right here, circle it. I'm not even interested in that anymore because I know it's positive. But I want to plug into this right here. What am I looking to plug into it? I need to do test values, right? So what would be a good test value for over here? Okay, so maybe try negative 3. In between here would be negative 1.5. In between here would be 0. Over here would be 3. And the only thing I'm interested in finding out is if my result is positive or negative. Okay, so if I plug in 0, what do I get? 0, 0, 0. I end up with a negative. If I plug in 3, what do I end up with? 3 squared is 27. And the 9, subtract, that's not going to be enough. So that's going to be positive. How about over here? Negative 1.5. So negative 1.5 times negative 1.5 is what? 2.25? And someone's going to have to help me on the next one. 2.25 times 1.5, what do we get? Okay. Go from there and add another 2.25 for the x squared. Okay, so what do we end up? Did anyone do this? What do we get for the region? Positive. And that makes this region over here negative. Okay. So I have negative, positive, negative, positive. And I'm interested in the regions that are positive. My inequality did not include the or equal to, so my brackets are rounded, and I want the positive regions. So I'm going to round bracket, round, and round, and then I'm going to start shading, draw an arrow, and I'll shade that one. Make sense? Okay. So let's do 8x to the third minus 125. So this is the difference of perfect cube roots. So this is really a to the third minus b to the third. And then the blueprint tells us that this turns into a, b, a squared, ab, b squared, and for minus it goes minus, plus, plus. Okay, so if this is what I start with, I want a minus b. Well, how do I go from a to the third to a? I take the cube root. So the cube root of 8x to the third is 2x. The cube root of 125 is 5. So then I'm going to come over here and I want a squared. Well, I already have a. So if I want a squared, I'm going to take this one right here and I'm going to square it. So 2x squared is really 4x squared. In the middle, I want a times b. Here's a, here's b. We completely disregard the symbols because they're already locked in from the blueprint. A is 2x, b is 5, so 2x times 5 is 10x. And for the last one, I want b squared. That's b. B squared is 25.
Isn't that also just saying 2x plus 5 squared? Isn't that the FOIL version of that?
I'm sorry, say that again?
Isn't the 4x squared plus 10x plus 25 the FOIL version of 2x plus 5? So you can simplify.
Yes.
What are you asking me if it's... No. Because look what happens when you FOIL. Outer's 10x, inner's 10x, gives you 20x. So that doesn't check out. Good question, though. Typically, sum and difference of perfect cubes, once you've done the blueprint, that's it. It's locked in.
Can you do the 3x squared minus 18x?
Which one? The last one? Okay, we'll keep going. So that one's not really as factoring. I mean, it is factoring, but not in the way that you think of it as. It's just pulling out terms they have in common. So 3x, because it's still considered factoring. So for this one, there is no real factor pattern, right? So I just say, well, what do they have in common? I can pull out a 3. I can pull out an x. And that leaves me x minus 6. Now, if this was a solving one, yeah, that's it. So if this was a solving one, it would be set equal to 0. And then you would set each one of these equal to 0. So that would give you 0 and 6. Make sense?
Yeah.
Is there anything else in the packet? We good? Okay.